Good morning, everybody. I've really been looking forward to coming today. I wake up every morning to change the world, and I think there's a few bigger chances to change the world than we have here today. So I think this is going to be really exciting. We saw a lot of cool materials, a lot of cool printers, the cool printer before. So I will talk a little bit about how we actually get some files we can print, small detail in the big picture, obviously, and also about how I see the different applications going forward. As you sense, I will speak fast. It's hard to me not to do that, so I will speak fast. So I hope stay tuned, and we will get moving. So very briefly about TreeShape. It was founded by Nikolai and Thijs in a two-room apartment in Copenhagen in 2000, and I joined as the first employee. So you can see slightly younger up here. There's Rune, and it has been really fun, and it still is very fun to do this. We actually started doing hearing aids. So the first many years, or 5 years, we did hearing aids. So it's a process where you go, you have an ear impression, often at the same material as you have in the mouth. You cut and grind, you light cure, you grind a lot again, and we basically digitalized that. So we made a scanner that could scan ear impressions. We got a 3D file. We made a CAD software that could design hearing aids, and we then printed hearing aids. So it's actually pretty cool at that time. This was in 2001. So we were the first to do mass customization on 3D printing in 2001. And we did it with a company that was called 3D System. So together with 3D System, in 2001, we were printing mass customized hearing aids, or we were printing individualized hearing aids. And today, 80–90% of all in-the-ear hearing aids are done with 3D printing, and the majority of ear molds are also done by 3D printing. And in 3 years, the whole industry went digital. From manual to digital. There was also another company working in the hearing aid industry at that time, doing materials for hearing aid. That company was called Vertex, or NextDent. It was headed by Rick. So he did materials for conventional hearing aids. Rick, over the night, lost his hearing aid business because everything went digital. And this is one of the main reasons, I think, that NextDent and the team has been so awake in dental, because they didn't want to have that experience one more time. So all our ways actually crossed all the way back in 2001, and we have been following TreeShape here at the 3D printing very, very closely. And I think it's my opinion, as Vijay was also saying, the most exciting time is right now, and especially in dental. All right, fast forward at TreeShape. So since the garage, we are now been growing a lot, especially the last year. We are only doing dental today. We are only doing scanners and CAD software. And we are today 1,300 people. We hired 400 people last year, growing more than 50% in our staff. So this has been super cool. It is still fun every day to wake up, change the world, and improve patient care. You can see we have a lot of patents. TreeShape, we wake up to do great products every morning. So we have more than 400 developers committed only to do scanners and CAD software. So let's look at that. So this is actually all the indications we can do on lab side today. And we can do virtually all indications, all lab work that is done today, lab side can be designed. There's a few a little bit more exotic applications that are missing. But overall, we can do the majority, and those we cannot do yet. It's just a question of time. The real challenge is on the material and manufacturing side to make those indications truly fly and become attractive. So let's take a look at the different key indications here. And trends. So one of the biggest trends is actually intraoral scanning. So as you might know, we have an intraoral scanner called Trias. It's a fantastic product. Go and see it at the show if you haven't seen it yet. We have been asking all the dentists that didn't have a scanner yet if they want to buy a scanner or consider or plan to buy a scanner within the next 3 years. It's the 7 main markets in the world. And this was the number in end of 2016. To end of 2016, 50% of all dentists said that they were going to buy a scanner. And now, end of 2017, the number is going further up. So end of 2017, 56% of all dentists that don't have a scanner is considering or planning to buy a scanner. So this is tremendously going to transform the industry. And we are looking forward to be a part of that. I mean, we have the Trias. It is a wireless scanner. It's super cool. It's fast. It's accurate. I mean, how many of you have a wired phone today? It's always hard to predict about the future, but I think wireless is also going to happen here. So it's a cool scanner. Go and have a look. So what do people do today when they get intraoral scans? They are actually building models, and we will still be building models going forward, maybe not for all indications, but I believe the biggest 3D printing indication today is models from intraoral scans. And I have a personal ambition in my life is to get rid of gypsum. So I want to get rid of gypsum. Not everybody is going to have intraoral scanners. So I truly believe we are going to scan impressions when we are not going to have intraoral scans. And we will print models for many indications, but also single crowns might even go model-free. But still, printing is essential to get models going. And I truly believe, and I have good friends in the lab side that are trying to make the count factory and get rid of gypsum models. So printing is desperately needed, on this page. And we'll get back to how many people actually have printers at the end. All right, let's move forward. So guided surgery. I think many of you are familiar with guided surgery. I love guided surgery, but I will ask you as a patient. So imagine you're a patient now. You walk into a clinic. Do you want to do get a freehand surgery, or do you want to have a guided surgery? So you want to have a flap, do you open the flap, or do you want to just have a tissue punch? Do you want to leave the dentist like this, or do you want to leave the dentist like this? Do you want to heal for the next 3-4 weeks, have pain, or do you just want to eat a painkiller? What do you guys prefer? What do you think patient would prefer? And you don't have to raise the hand. So anyone prefer the left side? There was one down there, okay. So I'm sure that guided surgery is going to boom. And actually, this is one of the places where 3D printing and the latest years of development of 3D printing have had the highest impact. Because a few years ago, guides from Nobel Biocare and others were costing hundreds of euros, many hundreds of euros. Today, you can print a guide for $10 on material cost, even less. So guides have become so accessible and so inexpensive. And at the same time, software has progressed massively. So guided surgery, in my opinion, should be mandatory to do because it's such a much better patient experience. And the cost now means that it's accessible for everybody. And this is where 3D printing over the last couple of years have radically changed the way we work because of the price point coming down. Basically, you take a scan, a CBCT scan, and the CBCT is actually one of the main barriers because you need to afford a CBCT scanner. You plan, you design, and you can then print. That's just a small software video here showing you how it works in the software. Normally, I will do live demos, but I don't have time today to do live demos. But this is really easy, very intuitive software where you first plan the implant, place the implant, and then you do your guide here. And again, you can do that in 5 to 7 minutes on simple cases, a little bit more on complex cases. There's also a big trend now that people are outsourcing to design services or get labs to plan for them as a dentist. So again, one of the things that's going to boom, and I think also Rick can confirm from a material point of view, that this is selling a lot already. All right, another super exciting application is splints and also appliance design. So we have already a splint designer. We are right now building a new with a lot of cool features. I think alone the splint application can justify to buy a printer. Compared to milling, compared to conventional, just doing splints can justify buying a printer because the return on investment case is so strong. And in some markets, in Germany, for instance, you get 400 euros in reimbursement for a splint. So we see splints booming in selected markets. And yeah, it's almost a no-brainer to buy a printer just to do splints. And material quality is also going up, what I hear from people in the market. All right, then we talked a little bit, Menno was talking about indirect bonding before. And here you see indirect bonding. So we'll get a little bit back to clear liners, but let's start with branding or brackets. Bracket is still huge business. And today you glue them on, by hand, and it's a cumbersome process. And it's not just cumbersome, also you don't get the right results. Because when you place them by hand, you don't get the positioning right, which means that you don't have the right forces, you don't have the right torque, you could say, by random placement. So indirect bonding is not just easier, it also gives you much better results. And And we have, again, together with NextDent here, developed a material. So initially, you know, what you did and what you see up here, to be a little bit more clear, is you have the target there on the left. You have the bracket placement there, and you can move, you know, the teeth, and you can even predict and calculate forces going forward. So really, again, a super exciting application. Previously, a couple of years ago, we started printing the models with the brackets merge in, and instead now, and then vacuum form. This was a very, you can say, indirect way to do a bonding tray. This is much more cool now to go, and we now directly can print the indirect bonding tray instead of this printing the model and vacuum forming. So really, you know, another exciting application in a market that should not be underestimated in the auto niche, you could say. All right, moving forward. So probably the most exciting, maybe even call it hyped, application within dental right now is aligners. And there's happening heavily changes on the aligner side right now, on the market side, because end of October 2017, the majority of all Align's key patents expired, which basically means the aligner market is massively open right now, and we will see a significant inflow of competition coming both from established players, 3M and others, but what is even more important, I think, and one of actually the main launches here at the Chicago show is that 3Shape is very proud to announce and launch a clear aligner software solution. So labs, restorative labs, orthodontics labs, practice labs can now do their own clear aligners. In my opinion, this is the biggest business opportunity for a restorative lab, that is to being able to offer clear aligners. Clear Align's price point today is $1,250 in average. It's a lot of money for plastic when there are no patents anymore. So I think there is a huge opportunity for labs to embrace this business opportunity and start doing aligners. Aligners is a great treatment. We are great, appreciated Alliance building this market and pioneering this market, but now it's time for others to join, and we would love to help you doing that. So let's look a little bit on the workflow here. So what's the workflow we have? We have a process where we can scan either with the Trias scanner or with a model scanner or an impression. We then have a design software designing in-house, and you can actually see the software here, very speeded up. So we see here the software, you trim the scan, you put some bottom or base, you do a tooth segmentation, you can then move around the teeth. It will come with a proposal, but it's possible to move around the teeth. You can see some adjustments going on here. Again, there's a proposal, and there's do some more adjustments. You can check the angles, the movements, because of course there are limits for how much you can throw around teeth inside the mouth. So you're checking that. And you can adjust a little bit more. You can see now you have built, so the way, try to notice now, you can see the changes on the design. I think it was finished, but you could see how the teeth moved from one position to the other. And basically what you're doing is you are outputting 10, 15, 20 models printed. And again, the greater thing about the speed here, because on other printers where the speed is much lower, it takes very long time to print 20 models. If you want to do 5 sets of aligners, you need to print 100 models a day. It's a lot of models to be printed on some of the other popular printers in the market. So there's a huge opportunity here to go this. And again, a high-speed printer like the NextDent printer here is really attractive. If you don't like to design yourself, if you as a restorative lab or one of you guys are not experienced in doing aligner design, orthodontic design, it's also possible to work with design services like Full Contour. So Full Contour has a full-blown design service, designing aligners for customers, and enabling people even without that many skills to actually do clear aligners. Again, of course, you can print in-house, you can print in the mill, you can vacuum form, and you can, of course, also outsource. All right, then one of the other very interesting indications, and this indication is actually, Mene was already talking a little bit about it, is trays. I mean, people look at us often when I talk about trays. Why do we want to do trays? But what is really surprisingly, if we look at usage data and we can see what people are using, trays are booming. Trays are literally booming in design. A lot of people are doing trays, much more than I ever expected, to be honest. And why are they doing trays? This is still because the time you can do a tray in is 5 to 7 minutes. You can take an intraoral scan. Most people not do that. But you can take an impression scan, and you can, within 5 to 7 minutes, get a tray out and get going on a tray. So there's a tremendous efficiency gains on doing trays. Like to credit also NextDent and the team, because we actually developed the tray software together in close cooperation with them. That was actually, you can say, the first project we did 5 years ago, or 5 years ago. We actually developed the tray software with them, and the usage right now is exploding to our a little bit surprise, actually. Yeah, and again, sorry? I know you told me. It's not always, yeah. Still, you can be surprised. Okay, and another cool thing is also that if you have implant placements, you know, you can go and place, if you have placed implants, you can go and place the holes in the exact same position, don't sit and grind, and so on. So really, really a cool application, and very overseen if you don't have a printer. All right, then another exciting application is, generally you can say, talking about removables. And one of the things is, of course, RPDs, or partials. The RPD software, at least for the frameworks, have been at a very high level for many years. And we see a big group of labs, not as many as there should be, but a big group of labs doing RPDs. The challenge with RPDs is actually that you still have to print wax, as you see here. So you have to print waxed and cast because the laser sintering process is not financially attractive yet, or the results are not. So you need to cast. This is actually still a very efficient process. So you can save tremendous amount of time if you scan and design and cast. The only thing is you have to be careful when you cast because you are casting without a refractory model. So you don't have a model. You're casting without a refractory model. So you need to be careful at casting, and please follow the protocols. But here, again, in Western world, where technicians are disappearing on the removable side fast, then I think this is a great opportunity, and you have significant, very significant cost savings, maybe as high as 50% cost savings when you do it this way, according to labs I speak to. And we have thousands of labs doing RPDs today. All right, then to my favorite application here, and I share that with the denture queen sitting down here. Dentures is my hobby, normally. I modestly want to be a denture prince, not a denture queen. But yeah, and why am I interested in dentures is because I think that we have an opportunity here to disrupt. Other places it was interesting. At dentures, we can disrupt. So let's look a little bit on that. So we have spent tremendous time on developing the denture software here. So we can do a lot of the things that our friends from Exocad down at the back here is not fully able to do yet. And you can see here that we invested a lot in this for many years now. And all the things that says new, what was coming new last year. We have single arch dentures. We have really good immediate denture workflows. We can 3D printer mill optimized. We have full workflows for try-ins. We can combine gypsum models and impressions. And again, we have a lot of the major teeth libraries coming in. So let's just look a little bit on the denture here. So let's first talk about try-ins. So is try-ins necessary? Eventually not. But still, we need try-ins today. And looking into the denture world here, where I spent the last 5-6 years trying to get this running, one of my surprises have actually been that making a monoblock or printing, as we saw before, a single denture in one material is actually widely accepted. So all the people I know is actually fully accepting a try-in to be done in one material as a monoblock. And of course, 3D printed. Some companies want to mill it. I don't really believe in that. But for 3D printing, this is good. Ultimately, I don't believe we're going to 3D print the monoblock. Ultimately, we're going to 3D print the denture. If the denture is not good enough, we modify it and we print a new denture because it will be so inexpensive to print dentures. But try-ins are still needed to some extent. I know people like the denture queen don't do try-ins, to my knowledge, because you are so good and smart, and that you don't need, that you can cut down with the right tools. You can reduce the number of visits down to 2 or 3 visits, and not the 5, 6, 7, 8. But that is another discussion how you do that. So, but of course, digital also linked to that. So ultimately, you want to get rid of try-ins. But right now, the solution that NextDent have developed, having a try-in material, is really a really good solution. All right, and again, it's very cost efficient to print a try-in. If we then look at the different manufacturing options, there are many different manufacturing options. So if we just on the digital side. So another reason you can say why I'm so excited about dentures is that this is the big missing indication in CAD/CAM, right? People are effectively, yes, Evident and the Denture Queen and a few others are doing digital dentures, but effectively, the digital denture penetration is non-existing today for full dentures. So no one are really doing it yet. This is, of course, is the big missing indication. 20 to 30% of lab revenue is coming from dentures worldwide, depending on the market. So there's a huge opportunity here on the denture side. There are different ways. There are a lot of different methods that you can use over there. Kind of say the 4 main methods is the monoblock for injection, where you print a monoblock, you inject, you make a silicone matrix, you inject. Not really a digital methods is what you do today. You can do pre-manufactured teeth, you can do milled teeth in denture base, in a denture base, and you can do 3D printed. You can find a video on YouTube from IDT at Baltimore, show where I go over all this in more details. I don't have time for that today. So let's just look at a kind of a summary here. So monoblock for injection, it has a low material cost, but it's not really a fully digital workflow. Pre-manufactured teeth, it's actually not a bad solution. Pre-manufactured teeth have high aesthetics. The aesthetics, depending again on which teeth you're using, are very good on the pre-manufactured teeth. They are low cost often, but they can be cumbersome to glue in. The main problem with pre-manufactured teeth is that they are not accurate in the manufacturing process. They are getting that in some places now, but the majority of denture teeth are injected, and that means they are not accurate in the manufacturing process, and it's make them hard to glue in. It's difficult because it's hard to fly around a little bit to glue in. It's difficult to maintain contacts and occlusions, and it's problematic to reduce the teeth. There are ways to do it. I would definitely not write off pre-manufactured teeth. You can improve it with certain CAM softwares, and there are a recent solution that is just improving it. But it's hard to work with pre-manufactured teeth. I have had a long traumatic experience, but that doesn't mean that it will not be still around for a long time. There's also some with milled teeth and milled base. The overall problem, that's generally the Ivoclar solution. The overall problem with that, I mean, it's a super good solution, but cost is still at the high end. So that leaves us again with 3D printed dentures. And you can see here, it can be done in multiple ways. Either you can print the teeth, you can print the base, and you can pure them, you can print them individually. So if I should be honest, here you see the latest generation. I'm normally traveling with my own denture, but I gave it to a colleague yesterday. And this is new latest generation, and it looks much better than the normal denture I travel with. Is it the best denture you can get in the world? No. You can honestly make nicer dentures, in my opinion, with denture teeth today. But guys, for the mass market, for the 80–90% of the mass market in the US, or especially in UK, and in UK it's 98%. No, sorry. for the mass market, I believe that these dentures are more than good enough. And we should not always start at the top. We have to think about the mass market. If clinical properties are good on this, and we have to see the final proof of that, then this will disrupt. So what we see here is not just a new funny way to do a denture. The cost of a denture printed in material cost will be 10, 20 euros or dollars. It will disrupt dentures. It is totally gonna disrupt dentures, which is why I think this is so super exciting. Because here is a unique, and if hopefully it is flying, within a very near time, it will more radically change the way we are doing dentures than it has been. It has been a 12-year journey, or 15 or 20-year journey, depending on how you count. On dentures, I think we will see a very fast penetration because of the significant cost savings in the denture market. So really cool. I love it, and I'm super excited about this. And I'm not the only one. At least I have few more guys down here on the front that are excited with me. All right, there's a little bit about collecting, so how we collect. So before here, we are doing individual teeth, but we have also developed a system up here where you can see we do them in blocks. So we have a whole block together, making it even more efficient. So instead of gluing in individual teeth, you can just basically take the base and the teeth, print them, and click them together. We are from Denmark, where Lego comes from, so we have made a small Lego connection. So we can basically just click them together, and we are ready to go. So imagine we print the base, we print the teeth, we click them together, we do maybe a little bit polishing or lacquering or whatever we need to do, and we are ready to go. $20. Is that going to change the world, guys? So this is super exciting, and again, a place where 3D printing have more impact than most. All right, so now we're looking back at this, this complete table here. And so we are already checked out pretty well. So there's actually a lot of materials, a lot of indications, sorry, that we are ready to go with here, and where we have many advantages. Of course, we still need to see even better materials coming out there, but I definitely think that many of the materials are good enough. But and for the waist range of those indications here. But of course, there's the whole left side. What about all the crowns, the bridge work, the temporary, the inlays, the onlays, and of course, ultimately abutments and stuff like that? Can we 3D print the final crown and bridge today? I'm in doubt, to be honest. I will say I'm in doubt. I don't know, maybe you guys later, you will say something about. I'm in doubt as we are ready, but I'm not a second in doubt we will be able to do it. We will for sure be able to 3D print the tooth, the crown, even the final crown. And I believe today we are very, very close to be able to print the temporary. So there is a big temporary market already here. In Italy, 95% of all temporaries are lab-made. So there's a big opportunity for embracing. Clive will have a massive department just doing temporary. And with CAD softwares, you can design temporaries in a very efficient workflow. So where you just take a trio scan or scan an impression, you do what's called an eggshell, and so on. So I'm sure the temporary is right around the corner. Some will maybe even argue it's here now. The final crown, again, will be a challenge. It's a conservative market, but sooner or later, we will get there. All right, so that's interesting. So is labs embracing printers today? So we have a little bit market data here for VJ and friends here, because there are some very good numbers. So this is from a called Key Group survey, and 23% of all, and it's the most reliable survey in the world, in my opinion, on CAD/CAM. It's 400 labs in North America that have been interviewed. And we see here that 69% of all have a scanner. So I'm a little bit sad the number is so high, but there are still good opportunities there. But more interesting now is that 23% of all labs has bought a printer. That's actually surprisingly high. But more interesting is actually the next number, is that in 2016, 9% had a printer. And this is for end of last year. So 14% of all labs in the US bought a printer last year. Don't trust the last percentage, but 14% is a lot of guys want to buy bought a printer last year. And of course, this is very related to what have happened on the printer side, is that the printers, especially some of the printers, have become very inexpensive and very affordable in the market. So how is it looking for purchase intent? Purchase intent, 51% of all labs in the US are considering to buy a printer. 51%. It's not bad business. It's not bad business. And this is within the next 12 months. So say 13% are planning to purchase. That is 7,000 labs, by the way, in the US. and 34% are considering to purchase a printer. So printers are gonna massively roll in to labs. Yes, I believe worldwide, US is the leading country for printers. We have the highest penetration in the US, but the rest of the world will for sure follow closely after. So really, really exciting times, and if I was in 3D System or NextDent, I'll be excited. Of course, it's a competitive market, but I think with the combination of materials and printers, speed, and overall performance, this has a unique opportunity. All right, let's go a little bit on, and again, here, sorry for that. Last year, the purchase intent was 29%. So the purchase intent is up from 29% to 51%, and I also believe that this is largely applying for worldwide markets as well. Maybe the numbers are a little bit lower, but I see tremendous impact also in the European markets, and people are buying printers like crazy. You can also see it on Facebook if you go there. All right, so the ultimate question, of course, printers, milling versus 3D printing, who will prevail? Who will win at the end of the day? Printers, and there might be other terms to add here, but for sure there's very attractive material cost in my opinion. There's no material, less material waste. You're not grinding away half of a blank if you want to do a splint. You have lower equipment cost, and that might actually be one of the most important things. A mill, the cost of producing a mill is you need a linear axis, you need spindle, you need sucking systems, where printers is not uncomplex, but they are much lower in complexity, and material manufacturing costs, equipment cost will be much lower. We're able to go much lower than you will ever be able to do on a mill, in my opinion. So, and they will for sure be faster going forward. Maybe they're not faster on the single crown today, but they will go faster. So overall, on the milling advantages, there is of course still milling advantages. We'll still mill for a while, for sure. I mean, there are much wider material selection. For sure, we have all the ceramic materials here, and there are more aesthetic materials, at least in some categories. But overall, if I should answer, will milling, who will prevail? For me, the answer is clear. Printing will for sure prevail. Will it prevail tomorrow? No. But it will for sure prevail, and it will, in my opinion, it will prevail on all indication, not just the denture or the guide. So I think there's a unique opportunity. I think that printer, and not at least the materials, is a unique opportunity. So guys, let's change dentistry together, okay?